Let's do an example where we solve for all triangles such that alpha is 43 degrees, gamma is 79 degrees, and A is 30 degrees. Before I begin, a bit of information about the wording of this problem. So solve for all triangles. That means find the side lengths and angles for all triangles such that those triangles have alpha equals 43, gamma equals 79, and A equals 30. For this type of problem, and by this type I mean when you're given two angles and one side, as long as the angles don't add up to something larger than 180 degrees, you'll always get one single triangle which has the properties that alpha, gamma, and A are as specified here. But we'll see when we're given different information, we might get more than one triangle or perhaps no triangles that satisfy the given conditions. However, when you're given two angles and a side length, then you'll always have one triangle where you'll need to find all of the side lengths and all of the angles, again with the stipulation that the angles that you're given don't add up to something bigger than 180 degrees. Now let's write out our law of sines. So sine alpha over A is sine beta over B, which is sine gamma over C. And let's circle what we know. So we know alpha, we know A, and we know gamma. We also know B because we can add up the angles. Alpha plus beta plus gamma is 180. And so beta is going to be 180 degrees minus alpha minus gamma. So 180 degrees minus 43 degrees minus 79 degrees. And that gives me a beta of 53 degrees. So we also know this beta here. Now I'm going to use the law of sines in order to figure out B and C. So sine alpha over A is sine beta over B. And so filling in what I know that sine of 43 degrees over A, which is 30, has to be equal to sine of 53 degrees divided by B, which I don't know. However, I know all the other quantities, so I can solve for B. So I'm going to multiply both sides by B, divide by sine 43, and multiply by 30. Let's take it step by step on a new page. So I'll go ahead now and divide both sides by sine 43 degrees and multiply both sides by 30. So B sine 43 degrees divided by 30 equals sine 53 degrees. We'll multiply by 30. We'll divide by sine 43 degrees. We get a bunch of cancellation on the left-hand side, and we get that B is sine 53 degrees divided by sine 43 degrees times 30. Now using a calculator and ensuring that my calculator is in degree mode, I see that B has to be 35.101, and I've rounded to the nearest 1,000th here. Keep in mind that technically, since I've rounded, B is approximately equal to 35.101 and shouldn't be 35.101, it should be 35.131. Go ahead and change that, miscopied that. And now we know B. So I can go ahead and circle that. I'll go ahead and put a box around it as well to call attention to whoever's looking at my solution, exactly what B is. A lot of times when you solve these, there's a lot of work written on the page, and it's helpful to go ahead and box whenever you come to a conclusion about a particular side length or angle measure. So maybe I'll go ahead and do that for where I determined beta as well. And now all that's left is to determine C here. I suppose I don't know it yet, so I shouldn't circle it. You can use actually any of the law of sines that involve sine gamma over C. I'm going to use the fact that sine alpha over A is sine gamma over C because I rounded in order to determine B, so I don't want my round off errors to contribute to more round off errors. So I'm going to use the information that's given in the problem here. Although you could use the other one, it would be fine. So sine alpha over A is sine gamma over C, and I'm going to solve for C. And instead of filling in what alpha, beta, and gamma are, I'm just going to solve for C right now before I fill in the number. So I multiply both sides by C. I divide both sides by sine alpha. And I'm running out of room here. So there's a little bit of magic. Give myself more room. And finally, I'm going to multiply both sides by A. Again, I do this to solve for C because I'll get cancellation here and here. For the A's on the left-hand side, sine gammas will cancel. And we get that C is equal to sine gamma over sine alpha times A. Of course, feel free to do this in smaller steps if you would like. Now I can go ahead and use the numeric values of gamma, alpha, and A, so 79, 43, and 30, to get that this is sine 79 degrees over sine 30 degrees, sorry, 43 degrees, not 30 degrees, times 30. Rounding to the nearest 1,000th, I get that C is, and I'm going to put approximate here, 43.180. I'll box it, and that will complete our problem because now we have determined every side length and every angle measure of this particular triangle.